Okay, good. Today we are going to talk regarding some point that we review in the last lectures, but the focus point for today is how to use and do the coding in MATLAB section. Means that some definition and some theoretical part that we observed in the previous lectures. Today we are going to test and have some talk regarding the coding part uh, about them. Then I call it review some concept based on MATLAB codes and using the MATLAB image processing. This is the second section that we professionally just speak regarding the image processing toolbox. These are the examples that today we will see, and I wish that we can finish them. We should actually finish today because for the next lecture I have some other plan to do about it. And meanwhile of today, I will try to do the coding online for you with the MATLAB, but as the task and assignment, you should also repeat it. And also, if you have question, you can ask me later on private on beach. First of all, the first example that we have is regarding the just I think some problem happened. Hold on, please. Um, we have one tool in MATLAB which we call it image processing toolbox. Some prior and calculations, some prior formula are already there. What we are going just to learn how to use the function. Means that the needed part for us is that how to use them and have the analyzation regarding them. Okay, now you should have the pictures once more. Is it okay now?
Yes, sir, it's okay.
Okay, sorry, there was some problem with the, I don't know, suddenly my prompt. Okay, what I have done, I make my MATLAB part, MATLAB software open, and then during today, I will try to do the coding, but mainly I will do fast because we should finish all this. Okay, the first thing is that how we can convert the image type. As already we talked before, we have some function which are built in MATLAB to help us and do the most of the mathematical calculation part inside the MATLAB. And what we are going, as the person who wants to use it, we are just going to use this function. In MATLAB contains this function for converting the different image type. And here we examine converting to grayscale and the display of individual RGB color uh, with the following code. Let us test this code. I think maybe I should share my MATLAB window for you. And yes. Now, can you see my MATLAB uh, command part?
Yes, sir.
Okay, good. Maybe some of you have this problem. When I open my MATLAB, first I will go to script and then new script. Here it will create the file that I need. Then to using this section and part, uh, we can just copy paste from the code that already I made. Okay, this is the code here. What I will do, if you see all my code, first of all, I have some part that we call it close all. This close all will close all the figure, all the plots, all the things that you had before in your MATLAB. And then I will do the CLC, which will clear all the previous parameter, formula, array, whatever you have before. And then for the more safety, I will do clear all. If I didn't do that, then if suppose I use the same variable in the next program, what will happen? Then the code will have the wrong input address or wrong input, and then we'll modify or do the coding based on the previous data. But if you want to do it for the uh, program which your input is changed, it's better, and you should also uh, you should use these three line codes in the you should use these three line codes. Then if you see all my today code, what I will do, this part is fixed. Okay. As the next part, what I will do, I should have the part which input the image. Which image I'm going to use? I'm going to use the picture which name onion, and it's in the format of PNG. These are some pictures that are inbuilt inside the MATLAB software. And in the next line, you know that this onion picture is in RGB and it has the 8-bit RGB. How we know that it's 8-bit? Because we can take even the info from that image. We will test and see that what is the program. Let us do this RAM and first of all run this part. How I will run it? If I don't want to save it, just I will highlight it, then put the F9 or evaluate section. Now I expected that one array will generate with the name of D, and all the specification of my image go there. If you see it's written here unit 8, it means that this picture is 8-bit, and this is the array which contain my figure data. Let us open it. If you open this, you will see that the number, which maybe for you is not meaningful, but for MATLAB, as it see the any picture in the form of uh, matrix, it has the meaning. Okay. Then my job is to change it from RGB to gray. Then simply I can use this formula, RGB to gray, and as I put my input in D, simply I can do it. Okay. Then next line, I because I want to combine my plots and my figure in one plot, means I just open one plot. I will use the uh, function of subplot, and because I have two image, then it has two. In the first part, I will do the original image, means that I'm show D, and then uh, axis image means that I will display both sides by side, means that I will do them near. And then in the next line, I'm going to show the second image, which now it's converted into the grayscale. Let us run this program. Select evaluation section. Now I expected, okay, this is the side by side we'll do. How I can suppose remove that? Just if I remove this, let us see what will happen. Okay, this distance little bit it's become less. Well, um, what I have here, I have the RGB pictures at top and then gray scale at the bottom, which can be the starting node for us. On the other side, you will see that I generate one D gray array which has the same dimension and same data, but the thing is that uh, it's in the gray level format. Uh, one more things that I wanted to tell you. We had one statement which is it's regarding the information about the image. If you forget the syntax, just you can use like this image info. Okay. Then here in the help, it said that image info is the command which will give you the information regarding your image. If I want now to use this command, simply I can use the uh, commands that they give in help and then copy paste it here. Suppose I want to know more information about image D that we had. Let's see here if I put the image info D, is it work or no? If it didn't work, then we will go for the next part. Okay, you will see here. I have some error that it said that the first input argument must be the valid handle structure or file name in the image info. And we have some problem regarding the input. Is it about these inputs we have? Okay, simply we can return back and see that what is this. Okay, there is some example here. Example, it said that you should do info and then I am info. Okay, and then put the name for that. We will do the same. Very simple. Copy. Okay, I am info and my photo name was onion. Then I will put the onion here. However, today you will just follow the method that I will use with the help. Okay, simple. What will happen? It will give the data. Here it says that the location of that, it's created on 2009. It's in PNG format. The bit depth, width, height, and color type is true type. Format is like these, okay, and so on. But what I have done, I changed the image into the gray. I put my image into the gray scale level. If I want the data of that image, I want to show you that it's not changed, okay? What should I do? Simple. After I am show the, maybe I can use now this D gray. Let us see it's work or no. If it has problem, again we will read the help. Okay, it has problem because yes, I didn't select it proper. See, yes, now. Okay, he said that file name is not something that they want. Okay, then how we can get the data about this gray level image? Maybe it could be some hint inside of my MATLAB. Simple, maybe just one image info will work for us. Let us see. If I put just I am info here, what will happen? Yes, Now you don't have that problem, and the data regarding the grayscale image is coming now. We can have it. You know, the location is same. All these things is same. Just the picture is in, and you will see that image mode time. See, 29 October 2009 is generated, and copyright is also with the MATLAB. These are some watermarks, some type of hidden data that we can have. Just I wanted to test this with you, that you can also check. These are some. Just review this code. Just review this code once again. What it will do, it just convert the RGB one to the grayscale. Once more, I run it. Okay, grayscale. It's the initial example that we had. Then let's go for the next one. Means that how we can read the 8-bit intensity image. Okay. You know that now you understand that some image have some a specification, which is just when they generated the um, picture and put it into the database, there is some internally they have some information regarding them. Let us suppose see. Let us see. Suppose we have one famous pictures uh, in the MATLAB, which people will call it cell. In the cell, which is the one 8-bit image, uh, and it's in the format of TIF. Suppose now we want to read this TIF one, because till now we read PNG and JPG. I want to show you that nothing is changed. The statement and command is same. Okay, it's need the edge. Just see that why we say this image is 8-bit. Let us run this. Okay, I read and then I put info, but info is not print because I put these two column at the end. If I remove these, it should give the information regarding this image. Yes, it's gone. Let us see this image first. Info. If you will see, it is black is 0. Its color type is grayscale here, and bit depth is 8. Okay, something that we said that 8-bit intensity image we have, height, the TIF format, and all. So what is the aim for this program? Is just I want to read it and show it. Simple. See, evaluate and run. This is my photo. It's 8-bit, and then I can do some other jobs also on that. Okay, I think yes. Now you should see this cell as the output also. Can you see the output?
No, sir. Oh, wait. No, oh, now I can.
Is it okay now? Can you see?
Yes, sir.
Oh, okay. Then here, this is the cell photo that we generate, and then we saw it as the output. That was how we can read the 8-bit of image. Let's go ahead and see the next example. Till now, that was not much more critical, but slowly we are going to change and do some much more natural. Okay, what we talk is that we can accessing the pixel, and we talk regarding the pixeling part in the image. Is that if I want to access some specific pixel in the image, what should I do and how it will work about that. Let me again, yes. I think now you should see my MATLAB part. Can you see the MATLAB part?
Yes, sir.
Okay.
Yes, sir.
Question is okay, good one. If one person say it's okay. First, you will see these is 3 fixed line, close all, clear all, CLC, which after running that, what will happen? The previous data will come out. See, everything is clear. Then the next point that you should aware about it, and you should know it, is that uh, first I should show my image. Okay, and after that, after this, uh, on my image, I'm going to view the resulting, and then I'm going to uh, do some specific job on one pixel. But if you see my code, I put b is equal to something. I am show b, yes. I am show b itself, if I run, it should give me the error. Why? Because now I didn't specify any image or any input for this function. Let me run it, you will understand better. Okay, evaluate selection. Yes, error is coming. Why? Because we didn't declare the image for that. What we should do, we should read and then show the image, the job that we had in previous part. Once more we will do. Okay, now it should show the cell. Yes, it's showing the cell. Let me show you the cell. Okay, can you see? It's showing the cell. Now again I will come back to my code, and inside my code I'm going to show and print a pixel value at the location of 25 and 50. It can be anywhere. Okay, and then on that exactly location, I will set the value of 255. 255, it means that RGB, one of these 3 color, should have the highest value that we can have. You know that we have the value of RGB, any of these channel between 0 to 255. Then here we will first go to that location, 25 and 50 inside my image, and then give the value of 255. Then I again show my image and view the resulting change in image. Then in the next part, I'm going to print the RGB pixel value at the location, and then uh, print only the red value, because now I just want to specify the value of red. How I know the value of red? Because this channel is 1. 2 and 3 can be red or can be blue or green. Okay, and then again set this value, and then I'm going to show the image. If I run this, I expected that one dot in the assigned location is running, and then you can see that, yes, it's gone. Let me show you, yes. But where is that? It's here. I don't know how much it's visible for you. Yes. Can you see this dot? Yes, here. This is exactly the pixel job that we have done. That is the location of 25 and 50 for my image. Could you see the image?
Yes, sir.
Okay, good. Let us continue. Then what we have done till now, we first reach the 8-bit image. After that, assign some specific value on the specific location of my image, and then show the result, which that was 1 pixel or accessing 1 specific pixel inside my image job. And let us continue for my image, but this time maybe we can test on other even image, and whatever image that you want. Suppose on my photo, you remember that I had one photo that I call it Atta, and then you may also have that uh, for inside your computer. My image was on F, and name is Atta, and the format is JPG. Now let us see what will happen on other photos. Run it. Yes, I changed the input. Okay. Here what happened, I specify the location in for my image as but in the wrong uh, matrix. Just if I change this B into a D into B, then it should work. Yes, it's come, but the problem is that due to the image, maybe you cannot find it easily. Uh, Maybe the gray pictures will be the better option for us to work. But here also I can see the dot. I don't know. Can you see the dots uh, in your computer or not? It's not important. We can test on some better image. Okay, one CLC, one more clear all, and then we can go for the next and one close all, and then we can go for the next program. Till now, we have the ability to find uh, an image, and then with that, we can accessing the specific part of my image. Okay, no. There was some problem in this code. Now I solve it, and then here. Okay, one more question. Suppose now I want to do one job. I want to read one image, and after that extract the red, green, blue channel, separate channel. You know that we have 3 different channels. How I can access these 3 different channels? Simple. Suppose if just I want the red channel as the first one, simply I can use this. I can just read it, and after that deread, then extract the red channel like that. Let us test this on the MATLAB side. Okay, there was some problem. Problem that you see, this C is cap. Okay, because I copied from my PowerPoint, it's take it in the capital. Okay, another thing is that this C should not be capital. Run once more. Okay, here if I share my output screen for you now, you will see that it's extracted just red channel. Maybe it's not total red, okay, but it's in the red channel. What about the, suppose, the green one? If I want to run the green one, same job I will do, and just run again my program. If I run it now, you should see that the green channel is also come to picture. Little bit it's darker, but it's pure green. And if I want to run the blue channel one, just same process, same job, but select the blue channel. Yes. Here are the output of my image that you can see, and you can see how I separate the channels. I don't know. Could you see the image, output image? Just give me the feedback that.
Yes, sir.
Okay, nice, nice. Here, what we have done, we separate the channels. Okay. Uh, can I test this on my photo, my own photo? Yes, simple. Just I should change the photo or the input image, and then run it. Very simple. Okay, there was one problem because I didn't put the proper statement here. Okay, if I run this, then yes, it's come. Oh, let me show you the output. Yes, this is the output. Again, one RGB picture, which is splitted into 3 channel of red, green, and blue. And then you can see that I just here select the I just select the channel 1 as the red, green, and the blue one, and show you the this spectrum or different color from my image. Okay, do one more thing. Suppose I want to now again work with some pixel and add some intensity inside my pictures. Okay, suppose add 100 pixel value to whole image A. Something like suppose I have the image and all the matrix value inside my image. Now I want them to increase by 100. What should I do? I can use the im add. Okay. First, I should read my image, any image. This cameraman is something a standard one because it's more visible what we will do. Then I show it and then add a 100 number, means that whatever I have in container matrix A, I will add it with 100 and then show that image. Let us run it. Yes. Okay. Now you should see this result is little bit it's more as the light than another one, which is the 100. Okay. Can I change? Yes. Put it into 400. It should become more bright. Let us see. Yes. If I put 400, you will see that total image become vanish and then you cannot see anything for that. It means that that 100 is the better option for us to working with that. Okay. What about my image? Can I work with my image also? Yes, simple. See, just reading is my image, and now I will run it. Okay, it's some problem. Yes, problem is here. Yes, now it's solved. I didn't want to save it. I don't want that it save this program. Okay, read it, and then after reading the image, you will see that the image is has lots of light. The light is increased by 100 inside that. Could you see this output? Yes or no? Yes or no? Is it visible?
Yeah, it's okay, sir.
Yes, sir.
Okay, why you have delay to answer me? I think you should wake up. Okay, let's do one nice job. Suppose I have picture number A and picture number B. I want to subtract between them. Means that whatever things I have in picture A, I want to do the subtraction between picture B. Let us see. Can we do that or not? Yes, it's simple. First, I should read the image A, then I should read the image B, and then show image A and B, and then subtraction. Before showing the subtraction, first I will show you image A and image B. Let us see. Yes. This is the output. This is picture A, picture B. Now I want to make the subtraction between these two. Means that what is different between picture A and picture B. Okay, let me do it. The statement is very straight. I am as image and subtract A and B. But this statement had some problem. But I will run, then you will see. Yes. See, this is the difference between picture A and B. This is what we could do the subtraction. But in even MATLAB help itself, it said that a useful variation on subtraction is the absolute difference between the absolute of any point. Okay. in image. Then if we want to avoid it, there is another statement which we call it diff A. And diff A is more effective than this subtract. See, this is the uh, diff A statement. Here I have again image A, image B, but I have image abs diff. Means that it will take the absolute with any points of picture A and B and then show it. Let me run it. Yes. Now you will see. It's more informative than previous one. In previous one, you just had the button, but now you have the real subtraction between A and B. Okay. Let's do one more program, and then after that, we will take some rest, and then we'll come back. Multiplication, also we can have multiplication and division, which both of them can be used in simple means of contrast adjustment. Suppose I can reduce the contrast to 25% or into the 50%, and this procedure is sometimes referred to an image as a color scale one. And similarly, division can be used for image differencing as dividing an image by another gives a result of 1 where the image pixel value are identical and a value not equal to 1 when difference occur. However, image differencing using the subtraction is a little bit complex, but more efficient, and we can do this job in the previous program in the next program that I will show you now. I'm going to do the subtraction, but in the form of multiplying and division. Here what I have done, read image 1 and B and then show them. Let us see what is image 1, what is image B. Yes, image 1 and image B. It's here. We can see. Now suppose if I want to multiply image A by 1.5 and divide it by 4, what should I do? Simple. I can have this coding job there. Here I can put the multiply of A and 1.5 and then show it, and also division by 4 and then show it. Let us run this program. Right. Okay. Now you can see they multiply by 1.5 and divided, which is act as the subtraction that we have before. Can you see this image?
Yes, sir.
Yes, sir.
Okay, good. Okay. Now, before I'm going for the arithmetic operation, we can have just 10 minutes rest and then come back and do the job. But before that, please turn on your camera that we do the attendance for school, and then we can have 10 minutes rest. Okay. Can we start? All already or no?
Yes, sir. We can start.
Yes, sir. Yes, sir.
Okay.
Ready,
Good,
sir.
thank you. Good. What we have done till now, we learn how to do the addition, subtraction, multiplication, and division. Can we do all the arithmetic operation? in MATLAB or no? Yes, we can do. First, please remember the example that today I bring for you. You will not find them easily on the net. Maybe you should do lots of search. Then please uh, copy and do the same PPT that with same code inside my PPT. That today I will share. I mean that please repeat this example yourself also. If I want to do that, first of all, that tree line is fixed. Means that CLC, clear R, and close R. And then reading one camera. I read, suppose, cameraman image, TIFF. Okay. Now, because I want to do to have 5 section, I make my subplot as a 5 section, and then in the first one, just I show the image. If I run this, just it will show my first image here. Or okay, let us see new share. Now, yes, this is the image. That image A, that cameraman. Why it's small? Because I want to add and do lots of more things now. Just I wanted to show you the first image as image. Okay. Then second image, suppose I will select the rice image and then show the rice image. Let me run it. Okay. Now it's come. Can you see image B as rice?
Yes, sir.
Is it visible? Okay. Then now I will make one matrix, and through that matrix, I make the size of A is that equal to that. And then because I want to do the subtraction, addition, multiplication, division, all of them, first of all, your both image should have the same dimension. Then with this routine of the for loop, you can just have the same matrix dimension, and you have the 256 by 256 and with the 8-bit resolution image. Now what I will go, I'm going to shows the image C after this loop, after these 4 loops that I have done. See, this is my image C, which inside of that, I will select one zone with the dimension of the 255 by 255, and then specify one part or one window through that. Now we will start. If I want to add picture A and picture C, it's like this. See, picture C come and sit here. If I want to add picture B and picture C, you will see picture B was rice, picture C was that dark photo with the window, and I show it here. If I want to add picture A and B, yes, this is A and B, which are combination of rice and that cameraman. Can you see the output or no? Output figure is visible for you?
Yes, sir.
Yes, sir.
Okay. Let us continue. Suppose if I want to do the subtraction between A and B, means that A and C. Suppose A minus C, let us do more. A minus C, B minus C, A minus B. All the possible value like that. You will see A minus C, B minus C, A minus B. It's nice. What about multiplication? Suppose A multiplies C, B multiplies C, B multiplies C, and A multiplies B, C. All are like this as the result. What about division? A divided by C, B divided by C, and A divided by B. Simple. And this is the A multiplied by C, B multiplied by C, and A divided by C. You will see this job, as we call it, arithmetic operation for the image. But sometimes in some application, one job we need, and that is I want to invert all my color. What I mean by invert, think, please see here. Suppose on the same photo of that camera person, yes, on the camera person, let me do CLC, close all and clear all, yes. In this photo, I want to invert the color or make it something like negative. I don't know that you remember the negative photo that we used, suppose 10 years, 20 years back, or some of you are 20 years already. I don't know that you remember or not. There was some negative film before this the digital camera that they will made the negative, and then based on the negative, they built the photo. Maybe we want to do the same. See, this is the negative, or this is the invert picture. How I will do that? This is the command, in complement, which invert my image, and after that, just I display the image here. Could you see the output?
Yes, sir.
Yes, sir.
Okay. Maybe some person tell us that, okay, what's the need of negative? Negative itself, it has lots of nice things that we will see later. But if I want to give you, suppose, one small hint, think that I want to remove this person with the camera from the background. This negative job can help me to, suppose, first extract the people and then suppose changing the background and put it there. Now, baby, when you work with the Photoshop software or Adobe software, you will understand that all of these coding are there, and just when you select any tool, you're running the code exactly inside of the Photoshop, and then they will do that. This job is very demanding Photoshop, that they change the background of the image. Do the same technique that I give you. Okay, that was very short on this, but what about the other part? Yes, in the continuing of that arithmetic job, we can also do the logical operation job. In this logical operation job, 1 minute, please. Yes. You know that we had even the DST lecture. In that we have or X or like that, and which are the useful for processing the binary value of the image. And sometimes in some of the algorithm is used to detect the object which have moved between the frames. Binary objects are, that typically they are produced through the application of thresholding to grayscale image, which today I will talk regarding thresholding also. And logical and is commonly used for detecting difference in image and highlighting the target region with the binary mask or producing the bit planes through an image. This operation we can do also on the image. Here I bring one example. same as that cameraman. But now on cameraman, we will do this logical job. See, first I read the image, same, and then read the image B. Now suppose I want to do the AND between image A and C, A, B and C, A and C, B or C, A or C, A, X or C, A, and so on. And then not A, not B, not C, like that. How we should do that? It's very simple. By using the, if I want to do the AND, I will use beat and A and C. It's for AND. For the OR, beat or A and C. It can do. XOR is like that, beat X or A and C. And if I want to do the complement, beat CMP. This command and this task will do it very nicely. Let us see the output. Yes, it's gone. And now you will see. In this lecture, I'm not searching much more for analyzing the photos. Otherwise, we will see the act. But here you will see that not A, not B, and not C is how much noise. A or B, it's something like adding the picture A and B, combine them together. A and B, it's multiplication of them, something like that. AX or B, not C, what will happen? You will see all the logical operation now here that we can perform on the image. Is there any condition? Yes. Don't forget, image A, B, C should have the same dimension. Okay. And even if here I can show you, see, picture A is 256 by 256. B is also, C is also, and all of them are 8-bit. Don't forget, if your image will not be in the same, then some of this operation will not work and you will receive the error command from the MATLAB. That was for logical operation. But one more concept that we review, that was threshold. You know that thresholding produce the binary image from grayscale one or color image by setting the pixel value to 1 or 0. It depends whether they are above or below the threshold value. Okay. This method is commonly used to separate and segment the region or object with image based upon its pixel value. In MATLAB, we can do this job by using the function im2bw, and then thresholding will come through 0 to 1. It's very simple, Lija. Even this work is very nice to detecting the object in the photo, but here you will see that it's very simple. Just in the code that I copy for you, we will read image, any image, and then convert it to the binary, but with the value of 0.1, and then I show it. Let us see if this code is working or not. Yes, nice. You will see that my original photo now take the threshold value, and then I could have new photo, which now the next process will can happen. Means that if I want to detect the object, then I should now start to do some algorithm to detecting the trees and like that inside my photo. Can you see the output? Why I
Yes,
ask?
sir.
Because yes, because why I ask? Because inside my Dingtalk, sometimes it shows that the output is not shared. If I ask, please answer me fast that we can continue the today lecture. Okay, now you see.
Yes, sir.
Yes, sir.
Okay, let us continue and see that what else I could for you. Okay, you know that in the pixel job, we have point-based operation on image. And the dynamic range of image is defined as the difference between the smallest and largest pixel value within an image. We can define certain function transform or mapping that alter the effective use of the dynamic range. These transformations are most of the time they are primarily applied to improve the contrast of the image, and this improvement is achieved by altering the relationship between the dynamic range of the image and the grayscale value that are used as they represent the values. In general, we will assume, suppose, one 8-bit with a 0 to 25 value grayscale range for both input and resulting output image. But this technique can be generalized to other input range and individual channels from the color image. Let us see the performance of this uh, transform. And as you remember, we talked in our lecture regarding the logarithm transform. How we should do it in the MATLAB, it's with the code that I bring here. First three line is fixed. Let me activate that. Yes, activate. First, I will read my image. Suppose that famous picture that we have, cameraman, and then I do the subplot of my image and show it there. Then ID double I, and then through that I will do the logarithm transform as output 1, output 2, output 3, and then I will show each output with the formula that we have. The formula was 2 multiplied by log, I call it output 2, 3 is output 2, and 5 multiply is the output number 3. Let us see the output from this photo. Yes. Oh, it didn't come. Yes. Now you can see. Is it visible? The first photo. Can you see?
Yes, sir.
Okay. The first left-hand photo is the original camera. Second one is transform logarithm, which multiply by 2. Third one is multiplied by 3, and fifth one is multiplied by 5. Then the concept of changing the contrast of the image, here you can see. Suppose now if you see the last photo, means that multiplied by 5. If I want to remove this person from background, now it's very simple to do it. But you should be careful. If you increase the contrast, sometimes you will lose the data also. And don't forget, all these jobs that we will do, transformation, I don't know, convolution, Fourier transform, all are will cause to leave the to lose some good data from our image source. Then please, if you want to do any of this job, first uh, try to secure the original image uh, and not damage your input image directly. Okay. Uh, Let us go for the next one. Next task from the transform are the exponential transform. That in this also, first we will read that cameraman person, and then we have the formula of the uh, exponential one, which I put it here, and then acted with three different parameters through that. Here you will see my original image, my output 1, which has this formula, output 2, and output uh, 3, which again you see that the intensity is increased, but little bit it has the smooth increasing, not like the previous logarithm one. Somehow it's acting, I think, better. But we had one more transformation, which I think I talked in week number 3 about it for you. That was the power one. In the power also, our aim is to increase the intensity. And now we will see here. You see that the second one pictures is very brightened, but data loss. Third one also loss, but somehow maybe the last one is better here. But selecting which one is good, which one is bad, it depends on your application and the quality of your image database. Don't forget this. Okay. Now let's do one application regarding the gamma correction. One of the common application for this power law transform is this gamma correction, which in that used to describe the correction required for the nonlinear output curve of modern computer analysis. When we display a given intensity on the monitor, we vary the analog voltage in proportion to the intensities required. Let us see the effect of this application. Yes, I just copy paste. Yes, you will see here that intensity as the result is increased, and the photo become more brighter than the previous one. The next things that we saw was the pixel disturbance in histogram, which in that we are going to analyze our image based on this parameter. Okay, let us do the job. And as you remember, I said that the command is I'm hist. Yes, this is my image and this is my histogram. Here it shows on the wave that with which domain it has the high density and which one is the last one. You can see the two graph here. But how it will help? It's something that we should say. Where we see the histogram plot with two distinctive peaks, a high peak in the lower range of the pixel value corresponds to the background intensity of the image, and the lower peak in the higher range of the pixel value correspond to the foreground object, I mean the coin one. Okay. Then with this we can maybe uh, have the two histogram related one photo in the MATLAB. Okay, then what about histogram for thresholding selection? In MATLAB, we can use image histogram as the basis for calculation of an suppose atomic threshold value. And for this, the function of gray thresh is the example that exploits the OSTO method. We choose that threshold value which minimizes the interclass statistical variance of the threshold black and white pixel. Let us check this example also. Yes, this is the output, which based on OSTO method, that this is one part of your task, that you should tell me what is OSTO method. Okay, don't forget to send it with task number 5. Okay, what about thresholding? We say that we have adapting threshold and non-adaptive threshold, which in that okay, I think just if we can continue a little bit, we can finish all this today, and it's good. In thresholding, we say that we have adaptive and non-adaptive one, but with the adaptive threshold is designed to overcome the limitation of conventional and global thresholding by using a different threshold at each pixel location in the image. This local threshold is generally determined by the value of the pixel in the neighborhoods of the pixel. Thus, adaptive thresholding works from the assumption that illumination may differ over the image, but can be assumed to be roughly uniform in the sufficiently small and local neighborhood. Let us see these codes on the rice example. First, I read the rice, and after that, I use the IM filter, which is create the man image, and then subtract the man image, and then threshold result, and then display it and display the result. Let us see how it's work. Yes. See, now suppose if my application is that I want to count the rice here, I can do it much more faster than other method. It can help me to count the rice now very fast. Okay, well, can you see the output here?
Yes, sir.
Yes, sir.
Okay. Okay, good. What about contrast scratching? In image histogram, we are also used to contrast the scratching, also known as normalization, which operates by scratching the range of the pixel intensities of the input image to occupy the large dynamic range in output. Let us see, suppose this image, which we know it as pout. In the pout, we are going to stretch the contrast using by methods and display again the image. See, now compare first image and second one. You will see that the contrast is adjusted here. Now you have the good image, which has the, I think, better quality than other one. Here we use the scratch lim function, and with that we are going to identify the C and D pixel value at the 5th and 95 percentage point of the normalization histogram. The IM adjust function is then used to map the range to be the maximum quantization range of the image. Um, this contrast scratching, we can also see the histogram based on that. Very simple with this code. And then yes, here now you can see the histogram of the image before and after this construct thresholding. You will see that now the histogram is spread out. in my axis, but previous time that was just in one place. That is why the second image we feel that it has the better quality. We talked regarding equalization, which is the second contrast enhancement operation, which is work based on manipulating of image histogram, is histogram equalization. This is one of the most commonly used method in image enhancement. Let me run it. Yes. Now you can see after this enhancement method, my image is better. And also histogram also I show here. It shows you that it's spreaded better than first one. First one, it's just put in between suppose 70 to 155. But here you will see that it's spread out between 0 to 250. Okay, what about then as the next target will be the histogram matching, which we taught before about the theoretical point of that. Here again, we will see the I am red, but if I want to match the histogram or I want to work probably with the contrast of my image, I should use this method. And then with this, you will see the linear output, which shows that the intensity and contrast is have the linear shape, and you can see the result, which is much more better than the original one. Histogram matches the extends the principle of histogram equalization by generalization the form of the target histogram. And then if we search for the adapting histogram equalization, uh, for the adapting one, we can use another code that I brought for you here. In that, adapt hist EQ is the method, and this is the output that you can see here in the image. And I think the last one, the right, is better than original one. You can see that some much more data is there, and now you can suppose extract the database. The main function is adapt hist EQ, and based on that, you can do this. But we talk regarding all histogram on the binary or grayscale, gray level image. But on the color image also, can we do the job? Until this point, we talk more about grayscale one, but attempting to improve the contrast of the color image is a slightly more complex issue than for grayscale intensity. At first, it is tempting to consider application of histogram equalization or matching independency to each of three channels R, G, and B. And is as achieve chromaticity, for example, subjective impression of the color, transformation of RGB value of pixel to improve the contrast will therefore in general alter the chromatic contents of the image. Here is the sample of doing the histogram on the color image. And what I have done, I just open the image and then convert the original to HSV image. And then through that, we take the channel of I2, like this is the third channel, then copy that and convert it back again to the RGB. Let us see the result. Yes. See that the contrast is changed on my image, and now you can see the difference between these two. Okay, for today my PPT job is finished.